Hi everyone. So this week we're going to talk about mapping, which is something that we haven't addressed too much in class so far, although obviously um, given the subject matter that we've been discussing about refugees and asylum seekers, we might be kind of surprised that we haven't gotten to mapping until now, in part because maps are such a frequent type of visualization that we see employed in this subject area. One of the reasons for that, of course, is that maps are just one type of visualization, and importantly, because maps are very often something that can and should be used sparingly. As I know I've mentioned in class, just because we have geographic data doesn't mean that we should map it. And we're going to talk about some specific case examples of that. However, there are some ways that maps can tell very powerful stories, and obviously they are a unique kind of visualization that it's important to know about the construction of and sort of how to think about them. For these purposes, we're going to be using yet another Google tool. There are a bunch of different kind of free mapping tools out there. Another one is called Cardo. I know the Google tool well, and I think it offers some really nice features. But that's not to say that there aren't others to be had. So this is just basically going to be an introduction to the basics of mapping, the things that you should be looking for when you want to do mapping. First, if we want to map something, of course, we do need data that has a geographic component to it. And so after poking around on the web a little bit, I came to the Eurostat database, which I think is probably familiar to some of you. And collects and publishes information, among other things, about asylum seekers in Europe. And so if I come to the database link here, one of the options is to browse statistics by theme. Very often the names of database tables are non-obvious, and we're going to see that and we're going to see a case in point here. And so if I choose this, this actually kind of harks back a little bit to the Sarah Cohen interview that we read last week, which is to say that very often to find what you're looking for, you have to do a lot of pre-reporting. In other words, the information is available, but understanding where to find it still takes a lot of work. So in this case, we're going to use the browse statistics by theme. Unfortunately for us, asylum and managed migration is one of the subtabs here. As is not uncommon, one of the things that we see here is a map. Which is great. It lets us know that, okay, at least there's something that seems like geographic data there. However, you'll notice that the map is basically the only thing on this page. And so the way that I am going to go about getting to the data that drives this map, if it ever renders, I suppose, let's refuse the cookies and see what happens. It seems that the map, as we can tell, first of all, is taking quite a while to load. This is first-time applicants. First-time asylum applicants by country. And so this is the range that they've decided to use for this. Because there's nothing else listed here, I'm going to go ahead and click on the source of the map. Whoops. And I will just, if this page just wants to behave. Wow, that's really annoying. Usability, folks. It's a real thing. So I'll point out here actually that Leaflet, the technology that they've used to render this map, is actually an open source JavaScript. I think it's JavaScript based. Yep, there it is, leaflet.js.com. Is another mapping platform that's available. Again, we're going to use Fusion Tables maps because they are easily accessible. You will not be able to use Fusion Tables maps with your Columbia account. You'll need to use a separate, a private Google account for that. I suggest, as you'll see in my case, that you make one that you use for mapping specifically. So here we go. We don't get a lot about it. You can see that the code, and this is going to be the title of the database, is TPS00191. Probably wouldn't be able to deduce that table name from anything logical, and hence the importance of being able to browse this data. So I'm going to go ahead and download the table. And save it to my desktop. One thing you'll notice is that it is in a .tsv.gz format. GZ is another form of zipping. If you're working on a Windows PC, you can actually change this file extension to .zip and it will decompress as well. And I'm going to open this TSV. TSV, by the way, is a format that is often used called tab separated value. So we often see CSV, which stands for comma separated value. Really what they just mean is there's something between the values. And fortunately, this version of Excel opens this automatically. If you try to double click this or right click and open this with Excel and it hasn't separated things appropriately, you may need to open an Excel file and then choose File, Import, and then select the appropriate options. So in some cases you need to manually say, hey, I want to have, let's see, where's my desktop? You know, I want to target this TSV file. And you have to do things like specify that you want tab to be the delimiter. But I think this has become more common lately, and so Excel is better about selecting it. So of course, now the question is what is in this database table? If we come back here, we actually see there is some metadata available. This is not always the case, and we can see what actual metadata there is. So this is kind of describing, this is extremely helpful to have, right? The unit of measure is the absolute number of persons. The reference period is the calendar month or calendar year. You know, this is important stuff to have. On the other hand, this doesn't very obviously give us, for example, a clear indicator of what's actually in here. So a lot of this we're going to have to deduce actually just from the data itself. And this is exactly the kind of stuff that you would want to go to an expert for and confirm or verify. They have contact information on this page. Doing maps is very time intensive because there's a lot of research that you need to do in order to understand the data in a map and make sure that you're representing it accurately. So if I look at this, I see that the top left description says citizen, sex, unit, age, asylum application, geo/time. Okay, so up here we can see that we clearly have years. And if we go down the rows here, we see EU 28, T, which I'm not sure the name of, P is persons, I'm fairly certain, total. In other words, if we look back at this and it says the age, this is the value they put in for age is total, as in the total number of asylum applicants. And then we see this two-letter code at the end. So AT, BE, BG, CH, CY, CZ, DE. As you all get more experience with this, you will actually recognize these. The final entry in this column is actually what the two-letter ISO code. So the way that countries are coded around the world, there are two primary formats that are used. There's two-letter and three-letter ISO codes. So we can look these up. Right, you can often find these like Wikipedia, and then there's a numeric code. There's also the so-called CIA three-letter code, and basically what we're going to be doing is we are going to be using this code to connect a number to a country, and then of course we have to get something that actually lets us render that country on a map. And to render the country on the map, we're going to be using something called Keyhole Markup Language, or KML. So KML is an open source, hopefully you'll remember from your reading, this is an open source markup language, very similar to XML. It's actually a subset of XML that describes boundaries, mapping regional boundaries. And so what I'm going to do is I'm going to just search for European Union KML. Let's see what that comes up with. I'm going to say European Union country KML. And hopefully we're going to find something. So we have world country borders, ArcGIS, that's a helpful one. Something like this, polygon data for European countries. I actually found one that was quite good. So let's say world country boundaries KML. Yeah, and so now that we have this come up, we're going to click on this link. This is actually already in Google Fusion Tables, which is handy because it means that we can preview the data that's in and make sure that it meets our needs. So I'm going to go ahead and click on this link. And so this is the Google Fusion Tables interface. If you don't have it enabled in a particular Google account, you may have to connect it as an app. So we'll go over that in class. But you see here that very handily this has the ISO 2-digit code for these countries. Much of the rest of this we can kind of ignore. The name and the geometry, which just says KML, that's shorthand so we don't have to look at it. We can, however, go in and look at it, and what we see is that this is a markup language. If you recall, although those many weeks ago, a markup language has those sort of carets, the greater than and less than signs, and we can have attributes and nested and nested elements as part of that. And so this is simply a convention that defines how shapes on a map are described using pairs or really triplicates of coordinates. So in this case, what you're seeing generally is the latitude, longitude. In this case, this is the elevation, which in this case, because it's a 2-degree map, is always going to be 0. But you can actually express even 3-dimensional information in KML. So just to check that this has kind of what I want before I go much further, I can add a tab here, and we'll see this again when we're logged into our own accounts. I'm going to choose Add Map. And to let you know that the default view kind of always looks like this, it looks like it's just points. If we zoom in, we actually see that these resolve, in fact, to outlines of the countries in question. So this is a good source code for us. Basically, what we're going to do is we're going to use a principle that's commonly used in databases. We are going to make a copy of this. We're going to download our own copy of this KML. We are going to modify our Excel file so that we are pulling apart this label, this DE label, for example, with, let's say, 2016 data, if that's what we want to show in a particular map. And we are going to tell Google Fusion Tables that we want to match or zip up the data such that we get on the basis of that 2-digit code. So basically saying, look, take this DE, match it to the DE, which I'm fairly confident it's in this table, somewhere down here. There's a lot of countries in the world, turns out. Takes so long. There we go. CZ, we saw that, right? Match it up to this DE. And then what we can do is we can use that to create what we call a chloropleth map, where either the shade or intensity or both of the country polygon is shaded according to, in our case, the number of asylum applicants from a given year. So see you back here in a moment as we start to actually do the process of creating these tables and generating this map.